Everyone, so today is lesson 5 and it is called Pascal's Triangle, and this is your Tuesday lesson for this week. I'm just going to go through the examples that I have for today's lesson so that you have an explanation instead of just looking at the examples written down. And after listening to this, if you want to pop onto a Google Meet and ask me for help, that's totally fine. So you are already familiar with expanding expressions like I have in the examples here. So you should know that a plus b to the exponent of 0 is equal to 1. A plus b to the exponent of 1 is equal to a plus b. Now, if we are multiplying two binomials together, such as a plus b times a plus b, we're going to use FOIL. So a times a times b times a, and b times b. And I've combined the two middle terms, right? A times b and b times a to give us 2ab. So this you know already from grade 10. And if you wanted to do a plus b cubed, essentially that is a plus b squared times a plus b. Right, so I have a plus b squared already worked out down here, and now we're going to multiply these three terms by a plus b. Right, so the same way that you would multiply two binomials, you're going to take every term in the first bracket and multiply it by everything in the second bracket. Or if you want to start with the second bracket, that's fine too. Multiply the a times a squared, a times 2ab, and a times b squared, and then do the same thing with the b. So you end up with 6 terms in total, and 2 of them I was able to combine, so I end up with 6 terms. And then to do a plus b to the fourth, it would work the same way, right? You'd have to figure out what a plus b cubed is first, and then multiply those 4 terms by the a plus b in the second bracket. So that's pretty tedious, right? Because if I wanted to work out, for example, a plus b to the 10th, that would take a long time. So there is a quicker way to expand these out. And that is using what's called Pascal's Triangle. So Pascal's Triangle is a special triangle where we start with 1 at the top, and the number below it is a direct addition from the 2 numbers that are right above. Right, so for example, the 2 down here comes from adding this 1 with that one, right? This 4 comes from adding 1 plus 3, right? These numbers together, and so on. So when we follow that pattern, we can come up with what's called the Pascal's Triangle. And we can use this triangle to expand binomials or other polynomials really quickly. So I'm going to show you how to write out, for example, a plus b to the 4th, I think we had. Yeah, a plus b to the 4th, right? So how do you write it quickly like we have here? Okay, so use the Pascal's Triangle. So what I'm going to do is take a look at the numbers in this row here. Okay, so I've got a 1, a 4, a 6, a 4, and a 1. So that is 5 terms. And these numbers here are the coefficients of those 5 terms. So I'm going to write those out in green. So right now, I'm just writing out my 5 terms with just the coefficient. So it's a 1, and I leave some spaces in between for the letters, plus 4, plus 6, plus 4, and plus 1. Okay, so those are my coefficients for my 5 terms. And then I'm focusing on the letters. So we have a plus b in a bracket. So I'm going to make my a red, just so that the colors are different. So my a is red, and I've got the largest, the exponent is a 4, so that I know when I expand this out, the largest exponent on the a is going to be 4. So that's what I'm starting with. So a4, and then I'm just counting down after that. So a3, a2, a1, and a0. And my second letter that I have is a b. And let's do that in purple. Okay, and the largest exponent for the b is also going to be 4, and that's going to be at the other end. So we have b4, b3, b2, b1, and b0. Okay, and now I'm just going to simplify, right? Like if we have b to the 0, anything to the exponent of 0 is equal to 1. So that's essentially going to disappear. So I'm going to be left with 1a to the 4th. My second term, we have 4a cubed b1, and then we have 6a squared b2 plus 4a to the 1 b3. And then the last term, a to the 0 is 1 again, so we're just left with 1 b4. And that would be the simplified expanded version of a plus b to the 4. This part a little further down just explains when the powers are written in proper order. Notice how the coefficients can be produced. So the coefficients just come from within the Pascal's triangle, and that's what's shown of all these being expanded out. You should have a copy of this handout. I believe it was the last page in the booklet that you got with the work that we did before the holiday break. And there is a little error there, so just make sure that you correct that. I think it was a 2 on your handout. It should be a 3. And then down here, I just have another example of how I worked out a plus 1 to the 6th. Right, so same way that I did a plus b to the 4th, same kind of idea. I'm just writing my coefficients first. So those are written in green in the first row there. And to the exponent of 6, the coefficients are right here. 1, 6, 15, 20, 15, 6, and 1. Okay, so I have those written in green, and then I start with my a's right after, and the exponent is 6. So I know that I'm starting with a6, a5, a4, a3, a2, a1, a0, and then do the same thing with the 1s, 1 to the 6, but from the other direction. So my 1 to the 6 is at the other end, right? 1 to the 6, and then I am going down, descending from the other direction. And then in the next row, I just simplified, right? Usually you will come across with some exponents of 0, so they just disappear, right? 1 to the 0 is 1, so you're just left with 1a6 or just a6, and so on. So you just want to simplify each time. This should be an A. It's a little bit messy. Okay, so that's what I wanted to show you today. If you could please hand in page 466, number 3, for ABCD, and 5A. I will be in a Google Meet from 12 to 1 again if you want to pop in and say hi or check in for attendance or ask me for help. All right, good luck with today's work.